All right, 19.3, translating trigonometric graphs. So we are going to look at the shifts in the translations with sine, cosine, and tangent. We are going to be talking not only A and B, but we're going to add in H and K. A stretches the graph vertically, that's our amplitude. B stretches the graph horizontally, it tells us how long it takes to repeat the pattern. H translates the graph horizontally, and K translates the graph vertically. So we have an equation over here. F of x equals 0.5 sine of 3 times x minus pi over 3 minus 1.5. All right, so that means we're translating our sine function, pi over 3 to the right, and 1.5 units down. To be able to do that, we have to actually graph the function f of x equals 1.5 3x. And we've done that, so we're going to practice that again. That means our amplitude is there. Going backwards and looking at how we graphed before and using that 5-point table to find where this value is, we're going to take our b value and we're going to multiply it times 2 pi. So b times 2 pi is going to be key. Now, our b value is, it says it's 3 up there, which means b is 1/3 times 2 pi. That gives us 2 pi over 3. That's what we're going to fill in our table. And remember, we're going to go by halves. So this is where things will get a little tricky because you're dealing with fractions. 2 pi over 3 times 1/2. That is 2 pi over 6, which is really just pi over 3. And if I take half of pi over 3, that's pi over 6. And then going between the 2 pi over 3 and pi over 3 is actually going to be pi over 2. So now, it's a sine function, which means we start at 0, we end at 0, and the middle is 0. This is our maximum value, which is going to be 0.5, and this is our minimum value, which is negative 0.5. Now remember, this is our parent function. So we're going to go here, and let's see, at pi over 6, remember, pi over 6 is this first value. We are up here at 0.5, and then we are at 0, and then at pi over 2 we're at negative, and then we are back at 0. So this is what our graph looks like. And I'm not so worried about keeping it repeating because I want to actually shift it to make the graph. So we have to draw this one in first. Now we're going to shift it. We're actually going to move it pi over 3 to the right and down 1.5 units. So every dot is going to go over pi over 3. These are all pi over 3 values. And we're going to move it down 1.5. So this point here is going to go over pi over 3. This is pi over 6. This is pi over 3. So we're going to move it over 2 units this way, and it's going to go down 1.5. So there's half, there's 1, there's 1.5. This point is going to go over 2, and then it's going to go down 1.5. You're going to keep doing this. So it's going to go over 2 marks and down 1.5. Okay? Then it's going to go over this one, 2 marks, and go down 1, think, yep, and a half, and it would be, so 2 marks, down 1.5 is going to be down here. And this one's going to go over 2, down 1.5 is going to be here. And I know it looks a little funky, but that's okay. I know it doesn't line up quite right, but you get the idea. That's how we graph it. So the black function is the one we actually wanted to graph. The red was just that parent function. That's how we translate. You got to get that parent in there. So looking at a tangent function, f of x equals 2 times the tangent of 1/2 x plus pi plus 3. So again, we need to look at what that parent function is. So if you remember back to your tangent ones and looking at those reference points. So looking at a reference points for the tangent, we need to get the basic function there. And the reference points, remember, are negative pi times b divided by 4, negative a, and then it's just that positive value. And that the asymptotes were negative b pi over 2 and positive b pi over 2. So let's go ahead and find where those are for our regular function. I don't know why I have this table. We're not going to use that table. So b in this case says 1/2. That means b is 2. So negative pi times 2 over 4 is really negative pi over 2, comma, negative a would be negative 2. And then we have the positive of that. So pi over 2, comma, positive 2. Those are my reference points. Here, my asymptotes, negative b pi over 2. So, again, b is 2, so that's negative 2 pi over 2, which is just negative pi, and then positive pi. So we need to extend our graph on this side. We have negative pi over 2, negative pi. So my asymptotes are here at negative pi and positive pi. My reference points are negative pi over 2, negative 2, positive pi over 2, 2, and it's going to go through there. And remember, it's going to make this little snake type looking graph. That is this function right here. Now, the translations say to move everything to the left, pi, and up 3. So that means everything goes to the left, pi. So we're going to continue to add on to our graph on this side. So I'm going to extend our line down. We have to go 3 pi over 2 and negative 2 pi. So asymptotes are being shifted down a whole pi. I'm going to do these ones in the black. Hopefully you can see that color difference. And then this one shifts over pi, which is going to put it here at the 0, 0. Now the reference points. Each of these points. So this point is going to go over pi, which is here, and then it has to go up 3, which is going to be here, because we're down at negative 2. This 0, 0 is going to go over pi and up 3. And then this point is going to go over pi and up 3, which would be up here at 5. And your graph is going to go along those lines. And that's how you shift and translate it. So we're going to still be practicing graphing, and then we're going to throw h and k in there after the fact.